Mr. Hopton of Iceotope.
Okay, who here can hear me? Everybody can hear me, fantastic. Great. Well, data centers. Who here has been in a data center? Can I have a show of hands? Who's been in a data center? That's quite a healthy number of people here who've been in a data center. These things cost $1,000 a square foot. They're probably one of the most expensive bits of commercial real estate. They're noisy, hostile environments, lots of noise, lots of fans. Sometimes the air's hot, sometimes the air's cold. And they're rather sensitive to dust, dirt. And that's because inside of these boxes you see on the screen here are lots of servers. And these servers have fans in them and draw air through the servers with these fans. These fans themselves consuming 20% of the power consumption of the servers. And air goes through the servers, it gets heated up, it gets ejected, and then something else has to cool that air. You end up with air conditioning. The air that goes into the servers has to be clean, very, very clean, otherwise it will block up the servers with dust and they'll die. And when servers die, the internet stops working. So if you don't want to break the internet, you have to have a clean environment. You also have to control humidity. And you end up with large amounts of infrastructure in here supporting the servers, and then you end up with infrastructure supporting the infrastructure. If there's a power outage, these things will overheat in 60 seconds. You end up with backup batteries, generators, all sorts of additional infrastructure supporting all that cooling infrastructure. Well, Iceotope is a liquid cooling technology company based in Sheffield in England. And it's our objective to disrupt this industry, to massively change what a data center is and remove waste. We're backed by Astor Capital, representing a strategic investment from Schneider Electric and Solvay Specialist Plastics, and also Ombu Group. We've got additional partnerships with Intel and 3M. And we're into what we call total liquid cooling. That is removing air from the equation and cooling everything with liquids. And those of you who have a physics background will think, well, okay, liquids, that's thousands of times more heat capacity per volume or per weight than air. And what we're aiming for is what we call the zone of benefit in infrastructure reduction, this benefit zone, this oasis. And that's around eliminating air from the cooling equation and getting your thermals to such a high performance that you can cool with hot input coolant and give hotter output coolant. And that's over there in that green box, which luckily is exactly where Iceotope sits at the moment. So up the left side, we've got air cooling. Then we've got indirect liquid cooling, where people put big radiators on the back of server cabinets. Direct, where people take coolant to particular components but still need air. But total is the magic one, where no air is required, and thus a whole lot of infrastructure starts to disappear. I talked about the elimination of waste. We're about eliminating waste infrastructure, but also waste power consumed in supporting those electronics used by that infrastructure. And ultimately, if we get the coolant temperatures high enough, we have a usable waste product as a result of running servers. This is our technology. I could probably go on about our technology for a few hours, but doing it on one slide is a challenge. We heat up coolants within sealed cartridges, sealed server blades, and we heat these coolants up and they become more buoyant. And we use buoyancy-driven flow in a state of ultra-convection to take the heat load from a very dynamic heat load of a server motherboard, and we spread it out so it can be taken very, very, very efficiently into water. And we use a coolant that's certified non-flammable, non-ozone depleting. It's got a very high thermal expansivity, and it's an electrical insulator. And our electronics are literally swimming in it, in a sealed cartridge. You take that technology and you apply it to a data center. This is what the data center looked like before. All these different bits of infrastructure here, each with a cost and energy consumption associated with it. And this is what a data center looks like after. We take out the raised floor. We eliminate half the UPS equipment. We halve the number of generators. We take out all the air conditioners. We don't need as much power distribution. We fit more than twice as many servers in the same footprint. Masses of cost eliminated. And then we get efficiency benefits. Our site, we have an evaluation and pre-production site we deployed to Poznan in Poland. They've reported that all of their servers are running full-time in what's called turbo mode, which offers 10 to 50% additional performance from the processors. So the same capital expense, and they're getting more out of it. And at the Leeds University, they discovered versus a state-of-the-art hybrid air-cooled and indirect liquid-cooled system versus a state-of-the-art indirect liquid-cooled system, a 40.8% improvement in performance per watt. So us versus state-of-the-art, the same electronics, and a 40.8% improvement in performance per watt. Dramatic efficiency benefits. This is the Iceotope system in Poznan in Poland. What we have here are the servers inside sealed cartridges, as I mentioned earlier, and they just hot swap in and out. We've slid our technology into the same user experience for the customer. They can go up, they can disconnect the cables, and they can remove a server in 30 seconds. They can take it away and bring in a replacement and click it into the system. These servers here have that coolant inside and water going around them, taking away the heat. Around the cabinet, the water circulates, and it takes the heat and it pushes it into these heat exchangers, where it can then be taken away from the servers outside of the building and radiated off, or even taken for useful applications. It could be used to heat an office building, or indeed, if it doesn't heat an office building, it could go maybe into industrial uses, maybe a swimming pool. And this is one of the servers just taken out of that. A sealed cartridge, not dissimilar in the user experience to a normal server, and the customer just docks it in. The same experience they already have. Hot swap, clean and dry is how we describe it. They may as well not even know this is a liquid-cooled system. They have the same user experience. They'll never see a coolant, and they'll never have to clean something up. And now for questions.
Peter, do you already make revenue?
We've sold 5 pre-production units, so 4 pre-production units, and we've built a further 3 pre-production units, which we use as demonstrators. We have our production products being announced in November, and we'll be shipping in Q1, Q2 next year.
Yeah, great. And do you need more money? Do you want to raise more money, or are you still well-financed for the time being?
We have well-financed backers in Asta and Ombu, who I'm sure will have the absolute pleasure to follow through, but always open to expressions of interest.
Okay, all right. We have a question from Gaia.
Hi, what is the biggest challenge you have encountered so far with this technology?
The biggest challenge in this industry is the status quo. We effectively have 2 markets that we're selling to, IT and facilities. 2 different decision makers, sometimes even 2 different companies. Co-location data centers, they're separate companies. Somebody rents the facilities and puts IT in. And we take those 2 things and we mash them together and remove all the waste that falls out. So we end up having to cater to both decision makers, both people in the transaction, and obviously there's a lot of legacy in that market in terms of those co-location. And so the status quo and the difficulty in changing the status quo is probably going to be our biggest issue.
So, sorry to ask such a specific question. One might have thought Intel Capital would invest as well. Perhaps reasons why they didn't. But what's the nature of your involvement with them beyond the comments you've made so far, please?
So we've got Schneider Electric on the infrastructure side. I mentioned we have those 2 different markets. The infrastructure side, the buyers like buying into a small set of brands. They're very brand conservative around the whole world, and they make a long-term commitment. And often they're not too worried about independence between the brands. On the IT side, the customers always want independence. They want to be able to, one refresh, they want Intel, the next refresh, they want AMD. So trying to have too much conflict on that side is an issue. Whereas having backers on the infrastructure side and the chemical side, and that offers a lot more benefit without the complications that could occur in the future.
Okay, final question from Florian.
Hi, yeah, thanks for a great presentation, very interesting technology. I think this whole area is one that's crying out for those kinds of efficiencies. But I want to just briefly ask, how far are you thinking along fitting this into wider smart home ecosystems? You talked about hot water as a side product. I mean, it would be quite logical to combine this technology with other types of passive energy houses or with other types of reuse of that heat that you're capturing. Is that something you're looking at, or are you simply saying that's not our role?
Smart cities, certainly. I mean, you think about a data center, they're these massive consumers of energy that are just dumped in somewhere, and all they do is consume resource. A 1 million square foot data center probably has 10 members of staff from the local community, but consumes all of the power from the renewable energies in the entire county or the state. You know, and then you'll have a river nearby, or say a Google data center, and they'll be evaporating 20,000 liters an hour from that river. You know, big consumers of resource and natural resource, but yet giving very little back to the local community. So I see the future where a data center like Iceotope-based technologies gives a lot back to the industry, to the local community. It gives it free heating. It gives it warmth to run greenhouses and hydroponics and industrial processes. At the core of a smart city is a data center. It runs all the smarts. How can that data center be part of the smart city instead of being a cost center?
All right, integrated solutions, that's how we like it. Thank you so much.
Thank you very much.
Peter, I get all these little things here from you. Great.